Hi everyone, this is Team Buy One get two free, and my name is Puchen Zheng.
My name is Yifan.
I'm Xiaotan.
And at this video, we are going to explain what we did for our final project, the steganography. And here we go. Hey there, this is Puchen Zheng, and for the final project, my job is mainly to develop the code for embedding and recovering the image. So right now I'm going to show you what kind of method I used and how I code to achieve this powerful method. So the first method we use to embedding the picture is called the odd even method. And at the first of this method, we use this function to flatten the hidden picture, which means we turn the hidden picture into pure black and white. And after that, we check every bit of the hidden picture. So when the hidden picture is equal to 1, which means at this bit is white, we just change the same bit for the normal picture into even. So if the original bit of the hidden picture is odd, we just -1 to make it into even. And if original is even, then we just leave it there and leave it still as even. And for when the hidden bit is 0, which means it's black, we just do the opposite way. So we leave the odd digit in the normal picture and change the even digit into odd digit. So right now, all the odd digit represent is black for the hidden picture, and all the even digits represent is white for the hidden picture. It's like we only change one every time, so it's like slightly different from the original picture. And for the recovery from the odd even method, we just do the opposite way. We check every bit in the embedded picture, since if it turns to odd, when it turns into odd, it represents at this bit the hidden picture should be black. So we just make the output at this point equal to 0. And otherwise, if this bit of the embedded picture is equal to is 0, which means it's even, we make this bit in the output into white. So we just get back the picture what we hidden in the normal one. And after that, we use this function to change this logical array into just expand it back into a RGB 3-channel picture. So that's all we did for embedding and recovering with using the odd even method. And the second method we use to solve this problem is called last 3-bit method. And for this method, mainly it's about when we open up a picture and we change it into binary and divide it into 8 pieces. You can find that the last 3 pieces is like it didn't really show what's the thing in the picture. It's like chaos, like points not in order. It's just like random points everywhere. So we use these 3 layers to put our hidden image in there. So that's why we have this function. Just put hidden image in the last 3, any of these 3 layers. So we can hide our pictures in that, and it's not obvious. We can see that after we see the embedded picture. And for recovery for the last 3 base digits, it's quite simple. It's just what we did to hide it. We just check the bit whether it's 1 or 0 and rewrite it into a normal picture and expand it as we did last time. Since there's RGB 3 channels and there's three last 3 digits, therefore 3 times 3 in this big method we can hide 9 picture, and for the last one, the odd even embedded one, there's also 3 RGB channels, so we can hide 3 different image in these 3 layers, I mean channels. So totally it's possible for us to hide 12 image, and for this project our mission is to hide only 10 image. So these 2 big methods, I divided them into 4 small methods, but that's enough for us to hide all these pictures.
This is Yifan, and I want to introduce the GUI part, which is the app designer. Here is the basic view of our app, and I want to detailedly explain the code which I write. So at first, it's the properties. The properties is like the global variable in C language, and we need to define the variable at here. And when we look later, all the variables need to have a class which is app. So let me introduce you some callbacks I used in this part. So first is the 3load button. I just right click it and go to the callbacks. For the load function, I use the UI getFire function to specify the filter of the image, and then use ImageRead function to display it. This part is to assign the location of the image which will be displayed. So this 3 you see is the load image part. Then I want to introduce the method. So this column is the hidden method, and this column is the recovery. This column is the recovery method. Let's look the odd even first method for example. So this OE embedding function is which my team member explained in before video. I just use the app.normal and app.hidden as the input. This one in here means the channel is 1, which corresponds to the red layer, and these 2 correspond to the green layer. The 3 at here correspond to the blue layer. So it has 3 layers which correspond to the RGB. And this is the 3 display ways of the odd even embedding method. Like the odd even embedding method, all the 3 methods we use has 3 ways. This is the RGB LSB method. Like the odd even function, we also use the function of last bit and to write down the input at here, which we have defined before at the property and load image. In each of the callbacks, I use image show function, which shows the embedded image. Use parent to make it visible, and I assign the location where it's supposed to be displayed, which is the UI axis 3. And the UI axis 3 is this one, the embedded image. To display the image, I use axis to create an area that the image will be displayed. Now let's look at the recovery method. This is the callback for the odd even recovery method. I use the odd even recovery function and then to insert the input of load embedded, which I saved after the hidden method. The save will be introduced later. Our recovery method is the same as the hidden method, so I just skip this part. Now let's look at the save button. I use image write function to save the embedded image, and this is the name of the save file. This is the class of it. The last one is the reset button. For the reset one, I just clear all the UI axis. When you click on the reset button, all the graphs will be a blank. So that is the app designer part.
Hi everyone, let me show how this app works. The first thing is load the normal image, then load the hidden image, then choose the function and save it, then load the embedded image, and we recover it. So this is the recovered image. Then reset it. Now we try the second function. The first thing is load the normal image, then load the hidden image. Then we choose the function and save it, and load the embedded image. Then recover it. So this is how this app works. Thanks for watching.